we're looking at a theorem which combines a matrix with its transpose and the concept of symmetric and skew symmetric. So let me take an example and make you guys understand. So what the theorem tells is, say we have a square matrix. I'm going to take 2 by 2. And we take the transpose of this, which will look like 4 minus 1. The row became the column. Second row became the second column. As it is a square matrix, the dimension will remain the same. Now, what the theorem tells is, if I happen to take A with its transpose, it should be a symmetric matrix. Let's have a look. So if we add the elements, this would be 8, this would be 1, 1 and 6. So that's nothing but your symmetric matrix example. This is turning out to be symmetric. Now, what they tell is, if I take A and minus of A, if I add them up, minus of A transpose, that is, it has to be skew symmetric. So let's pick up A transpose, the negative of it. So this is minus 4, minus 2, 1 and minus 3. Now, if I happen to add the required elements, we have 0, minus 3, and this is 3 and 0. Right? So along the diagonal, it is 0, and along the non-diagonal, you can see that they map. In terms of magnitude, they are equal, but in terms of signs, they are opposite. So this is nothing but your skew symmetric. So this is what the theorem talks about. So the proof is not that hard. It's actually quite simple. So given a matrix A of order n by n, the first part talks about a matrix which is made up of matrix A plus its transpose. If I happen to take the transpose of this, and we know that we can apply transpose at the individual level, so I'm applying it. A transpose of transpose is A itself, and this is nothing but B. This is clearly symmetric. Now, next thing, if I happen to take D, which is sum of A and its transpose, if I take the transpose of this, A minus A transpose, A transpose minus of A transpose of transpose. So we have seen this property with transpose. So A transpose minus A. If I happen to take negative sign out, I'll get the following result. And this is same as our original D. So D transpose happens to be minus 1 times of D. That is nothing but indicating it is skew symmetric. And that's our proof.